So this is on reducing the payback period. And let's see. So reduce the loan payback period. Okay. Last time I showed you that if you borrow $100,000, for example, at 6% annual interest rate and pay the loan in 30 years, then your monthly payment will be will be about $600. So you have $100,000 loan, and so the loan amount, the P is the money borrowed, and we are assuming that we are going to borrow $100,000. And our annual rate of interest, R, is annual rate of interest at which we borrow the money. We assumed it is 6%. Now, interest rate is always expressed in decimals, so it is 0.06. Now, our monthly small p is your monthly rate of interest, and that is equal to 0.06 divided by 12, because there are 12 months in a year, is 0.005. So we borrowed the money for 30 years. So our time period, T is your time period for borrowing the money, is 30 years, or since there are 12 months in a year, 30 years times 12 months per year. Oops, excuse me, I'll take care of that. So it is 12 months in a year. 12 months, so 12 months in a year and year. So this is T then is equal to T. My T is equal to then 360 months. Why am I converting it to months? That is a good question, because my interest rate is 0.005 per month. Okay. So last time we used the formula. I will show you what will be your monthly payment. M is your monthly payback amount. And that formula is given by M is equal to capital P, okay, times small p, which is the monthly percentage rate, 1 plus small p raised to the power of t as in time period, divided by 1 plus p to the power of t minus 1. Now, let me distinguish between small p and capital P. Small p is the amount you borrowed at the beginning. So this is capital P. Okay. Now, using this formula, so what we'll do is move it up. Using this formula last time, this formula we saw last time that the monthly payment, that M, the monthly payment is about $600. monthly payment M is $600. Now, then it will take you 30 years. Take it 30 years or 360 months to pay back the loan. Pay off the loan, I should say. Do you really want to struggle for 30 years? Please do not quit. Now is the important part I'm going to show you. Suppose I increase from $600 monthly pay, I just pay $100 extra. So my monthly payment now, suppose on top of 600, I'm paying diligently $100 extra. That is total monthly payment I'm making is $700. How much time it will take me to pay off the loan in that case? So let me make some space. Let me change the color of the ink. Okay. Or maybe we'll use red. Okay. So now let's make a let's uh, let's pay $100 extra on top of $600. Okay. Every month. I have to mention I do that every month. Then my then M is 600 plus 100 is equal to 700. Okay. My capital P is still, sorry, my capital P is still 100,000. I borrowed that money initially. My small p, as we shown before, as I've shown before, is 0.005. This is the monthly interest rate. Monthly interest rate. And P is 600,000 is the that we amount borrowed initially. Initially. Only thing I've increased my monthly payment by $100 so that I can pay off the loan a little bit earlier. That is the whole idea, how to get rid of the loan quick, earlier than what is scheduled. So let's do these calculations. So, so now I have M, which is 700. So plugging in M is 700. Amount I borrowed initially is 100,000 times small p is 0.005 as we discussed, and 1 plus p is 1 plus 0.005, and we don't know how long it will take to pay this loan off, so it is exponented to unknown t. The whole thing is divided by 1 plus 0.005 exponented to 2 minus 1. Okay, so my goal is to, so let me move this a little bit. So my goal is to solve for t. How long is it going to take if I've increased my minimum payment from 600 to $700? So what I will do is I will multiply by multiply by so by multiply, so let me write down both. Multiply both sides by the term in the denominator on the side right by 1 plus 0.005 t minus 1. This is the thing I'm multiplying both sides by time, or 1 plus 0.005 is 1.005. 1 plus 0.005. I missed a parenthesis here, so I better put that on. To the power of t minus 1. Okay, so I'm multiplying both sides by this. So now it becomes 700 times 1.005 exponented to t minus 1. That is the whole term I'm multiplying both sides, is equal to 100,000 times 0.005 multiplied by 1.005 t. This was already in the numerator on the right side. Now the denominator on the right side is 1.005 to the power of t minus 1. And of course, I'm also multiplying on both sides by 1.005 exponented to t minus 1. Now notice this term. So this term and this term, they cancel each other out because they're same. That's why I multiplied by that term on the both sides. I just want to clarify one thing. This t is on top on the outside, so it is exponented to t on the outside. So basically that extra term that which I multiplied by on both sides, on the right and on the left, on the right the term in the denominator cancelled with that extra term that I multiplied by. Okay, now let's do it this way. We will distribute now 700 on the left hand side to the terms inside the parenthesis. So I will move this up a little bit. So it becomes 700 times, it is that negative sign which is not there. So it is 700 times 1.005 exponented to 2. I distributed that 700, so 700 times 1 is 700. And on the right, I have 0.005 times 100,000. If I use my calculator, that will be 500 times 1.005 exponented to t. I just want to mention that this term cancels with this term as we discussed. Okay. So basically 0.005 times 100,000 on the right hand side in the numerator is 500 multiplied by 1.005 exponented to t. Now I will add 700 on both sides. So it becomes the left hand side becomes 700 1.005 exponented to 2. The two 700 they cancel out. I have 500 times 1.005 exponented to 2 plus 700. Okay. Now I will subtract 500 times 1.005 exponented to t from both sides. I'm subtracting, so what I do on the right, I will do on the left of the equal to sign also. And I will move this a little bit up. So 700 minus 500 on the left hand side, 700 minus 500, I have 200. So let me again erase. There's no negative sign here. So that is what I wanted to erase. 200. 700 minus 500 is the 200 I'm getting from. Okay. Is 200 times 1.005 t exponented to t. 500 minus 500 they cancel and I'm left with only 700. on the right. Now divide by 200 on both sides. So I'll be finally the 200 and 200 will cancel. I'll be left with 1.005 exponented to 2 is 700 by 200 on the right, which is 7 over 2, which is equal to 3.5. So let me move this up a little bit more, and I'll change the color of the ink to say blue. Okay. So now I have the equation is, I have a logarithmic or exponential equation to be precise. 1.005 exponented to 2 is equal to 3.5. Usually when we have exponential equation, you solve it using logarithm. We will take logarithm of both sides. So we have, why do we do that? Because one rule of logarithm is if we have exponent, then like t on the left hand side exponent, it will become a factor once we take the logarithm. Let's do that. So we have log. So let me erase this. So I have 1.005. 3.5 is 7 divided by 2, as I have explained to you. So when I'll take the logarithm of 1.005 exponented to t is equal to logarithm of 3.5. As I explained to you, the exponent in logarithm becomes a factor. So this becomes, on the left-hand side, it becomes t logarithm of 1.005 is equal to logarithm of 3.5. Now this is t multiplied by, right? So I'll divide it by logarithm of 1.005 on both sides. 1.005. Okay. So if I create some space, moving up, this on the left, of course, since I divided by logarithm, this term and this term, they cancels out. So t is now equal to logarithm of 3.5 divided by logarithm of, so let me write that correctly. It is not crossed out, it is just divided by. So this is logarithm of 3.5 divided by logarithm of 1.005. Now you have to use your calculator to find these logarithm. So I'm going to use my TI-84. I press the on button, then the logarithm button. Logarithm of 3.5 is on the numerator, and that is equal to 0.544 divided by logarithm of 1.005. 1.005, and that is equal to 0. That is equal to 0.002. So what is your t then? Then remember, this t will come out in months because we have monthly interest rate. So 0.544 divided by 0.002 is equal to 272. Again, this is months. So how many years is that? You divide that by 12 months in a year. So T is equal to 272 divided by 12 months in a year. So years. So that is equal to 272 divided by 12 is approximately 22.67 years. So what has happened now? What has happened? Initially, my payment was scheduled as $600 a month. And if I would do that, $600 every month, I would pay off the loan in 30 years, 30 years. But now I have increased my payment from 600 to just $700 a month. Additional $100. Remember, additional $100. The other parameters are remaining the same. Still, I borrowed 100,000, 6% annual interest rate or 0.005 monthly interest rate. And what happened when I go from 600 to $700 a month? I reduced my payment by almost 8, slightly less than 8 years. So let me make that clear. So now reduction by increasing monthly payment from 600 to $700, I have reduced payoff period by 30 minus 22.67 equal to, say, 7.33 years. That means payoff period has been reduced by 0.3 years, means almost by 7 years and 4 months approximately. Not bad. What did you do? You were very disciplined. You increased your monthly payment by just $100. Okay. And what did you do to yourself? You got rid of the loan 7 years earlier than what you would have done if you would have stuck to the monthly payment schedule of 600, which they originally prescribed for you. Here you got it? Point to note, increase monthly payment, reduce your total time of payoff, or you reduce your payoff period by more than 7 years just by increasing monthly payment by only $100. You have to keep doing it and you'll pay off your loan much earlier. Okay. So that is the point I wanted to make at the end of this presentation, that if possible, pay slightly more every month, then you will pay off your loan much earlier and get rid of the loans. Who want to be uh, hung up with so many loans, so much burdened with loan? We don't want that. Therefore, we increase the monthly payment by a slight amount and we'll pay the loan off earlier. Here I showed you an example. You borrowed 100,000 for 6% interest, annual interest rate. Your payment schedule was $600 a month. You increased it by $100. You reduce your payoff period by more than 7 years. Got that straight? I stop here today. Any question, any comment, please write me a note. Please give me a thumbs up if you like my video. That really motivates me to produce more good videos, interesting videos just for you. And also, please let me know what are the types of math problems you want me to solve. What else do you want me to solve? Please give me some feedback. I really appreciate that. Please give me thumbs up if you like this video. Share this video with your friends. And please do not forget to subscribe to my channel by hitting the red subscribe button. And please watch me tomorrow. Do not forget that. Definitely I'll be there tomorrow with another interesting video. Thanks for watching. Take care. Have a nice day. See you next time.